Welcome to breaking news to trading moves. Every single time you open a chatbot, type in a prompt, or, ask an artificial intelligence tool to generate code, it costs a company money.
Right, a lot of money.
Exactly. Power, cooling, computing time, it all adds up. But what if a company just built a custom engine designed to do absolutely nothing else but answer your questions for pennies on the dollar? Today, we're looking directly at a major headline from the technology sector. OpenAI and Broadcom have officially unveiled Jalapeno, which is OpenAI's very first custom AI chip.
Yeah, that is exactly the headline we are analyzing today. And to truly grasp the market winners and losers resulting from this development, we first have to, understand the hardware itself. So, Jalapeno is a chip built strictly for a process called inference.
Right, and for anyone who doesn't spend their days reading semiconductor manuals, think of an artificial intelligence model as a student.
That is a great way to look at it.
Yeah, so training the AI is like the student spending months studying for a final exam. They are absorbing textbooks, running through flashcards, processing just massive amounts of information.
Which takes an unbelievable amount of time and energy.
Exactly. Inference, on the other hand, is that same student actually sitting down in the classroom, taking the test, and answering the questions in real time. So when you use an AI search tool or enterprise software, the immediate response you receive is powered entirely by inference.
Exactly right. The training phase happens behind closed doors, often taking months and requiring thousands of processors running in tandem. But the inference phase, that powers daily usage.
Right.
So our focus is strictly on the headline regarding this new inference chip and what it means for the artificial intelligence infrastructure trade. The market is moving away from scarce, general-purpose graphics processing units toward custom silicon. And this transition brings lower power usage and gives companies far more control over the entire hardware and software stack. So we are going to examine the exact market winners and losers from this development.
Okay, so OpenAI has this idea for a custom chip, but they don't own a factory. I mean, they cannot just sketch jalapeno on a napkin and magically produce a processor.
No, definitely not.
They needed a partner to actually design and build it, and Broadcom steps into the picture here.
Yeah. The clearest winner in the design category is Broadcom, ticker AVGO. OpenAI chose Broadcom as the specific design partner for Jalapeno. This directly validates Broadcom's custom accelerator business model.
Makes sense.
It demonstrates that major artificial intelligence companies want chips tailored to their own specific workloads, rather than simply buying standard, off-the-shelf processors from a vendor. Another company benefiting from this specific environment is Marvell Technology, ticker MRVL.
Right, even though Jalapeno is a Broadcom project.
Exactly. While it is a Broadcom project, the broader message in the market is positive for custom silicon, artificial intelligence networking, and data center chip design, which are the exact areas where Marvell operates.
Okay, so Broadcom draws up the blueprint, they architect the logic. But a blueprint is not a physical chip.
No, you need physical manufacturing.
Right, someone actually has to melt down the sand, etch the microscopic transistors, and pour the concrete for these massive projects. Who is doing the actual manufacturing?
That process brings Taiwan Semiconductor, ticker TSM, firmly into focus.
Yeah.
Once you have a complex design from Broadcom, you need a foundry capable of producing it at scale. And more custom chip designs ultimately mean more demand for leading-edge foundry capacity. Taiwan Semiconductor operates the most advanced fabrication plants in the world.
Wait, let me stop you there and ask the clarifying question.
Sure.
My immediate instinct is that if companies are moving away from standard general-purpose chips and building their own specialized custom chips, wouldn't they buy fewer semiconductors overall? Like they're cutting out the middleman, so to speak.
I see what you mean.
Yeah. How does a move to custom chips translate to consistent or even higher demand for the manufacturers?
That is a very common assumption, but the reality is actually the exact opposite. Custom artificial intelligence chips do not reduce overall semiconductor demand.
Really?
Yeah, they actually have the potential to increase it, primarily due to the sheer complexity of what is being built. The manufacturing required for these specialized chips involves incredibly complex architectures. We are talking about advanced packaging techniques and rigorous defect testing.
Right.
Because the specifications are so demanding, the foundries need more equipment, more materials, and more time on the production line just to yield functional chips.
When you say advanced packaging, what does that actually mean for the hardware? Are we just talking about like the plastic box the chip comes in?
Oh, no, not at all. Advanced packaging refers to how the microscopic components are physically arranged. In the past, you might lay out various processor components flat on a motherboard.
Kind of like a sprawling suburban neighborhood.
Exactly. But to achieve the speeds required for artificial intelligence, data needs to travel shorter distances. So instead of a flat neighborhood, chip makers are now stacking components on top of each other, creating like a 3D skyscraper of silicon.
Building a microscopic skyscraper sounds like it requires highly specialized tools. You cannot just use standard assembly line robotics for that.
Precisely. You cannot build these incredibly complex circuits without highly specialized machinery. That is why companies like Applied Materials, ticker AMAT, and Lam Research, ticker LRCX, emerge as winners here.
Because they make the equipment.
Right. Advanced chip production requires the complex equipment that these companies manufacture. The specialized nature of Jalapeno requires highly sophisticated supply chain. If Taiwan Semiconductor has to build 3D skyscrapers of silicon for OpenAI, they have to buy more deposition and etching machines from Applied Materials and Lam Research to do it.
Okay, so Broadcom designs the blueprint. Taiwan Semiconductor builds the skyscraper using tools from Applied Materials and Lam Research.
Yep, that is the chain.
But who is actually buying these finished chips and plugging them into the wall? We have to look at the massive technology platforms deploying them.
The hyperscalers are the next set of winners. And when we use the term hyperscaler, we are referring to the massive cloud service providers that operate data centers on a global scale.
Right, the guys.
Yeah, large platforms benefit immensely from custom chips because it gives them tighter control over supply chains and hardware performance. Microsoft, ticker MSFT, is a key beneficiary simply due to its direct established relationship with OpenAI.
Makes sense.
By utilizing custom hardware, Microsoft can run OpenAI models far more efficiently on its servers.
And it's not just Microsoft playing this game. I mean, Alphabet, ticker GOGL, Amazon, ticker AMZN, and Meta platforms, ticker Meta, are all investing heavily in their own artificial intelligence infrastructure and developing their own in-house chips.
Right. Google has the tensor processing unit, Amazon has Trainium and Inferentia. Meta is working on its own accelerators too.
The business case here just comes down to strict profitability, right?
It does. If inference becomes cheaper to execute through these custom chips, artificial intelligence products across cloud computing, search engines, digital advertising, coding, and enterprise software all become more profitable.
Let's break down the math on that because I think this is vital for you, the listener, to understand. Every single time you sit at your desk, run a prompt, or ask an AI tool to summarize a document, it costs the provider money.
Real money, yes.
We are talking about computing power and electricity. A standard general-purpose graphics processor answering 1 million queries might use enough electricity to power a small town.
And that is exactly where precise hardware design changes the equation. A custom chip like Jalapeno is optimized to perform the exact mathematical operations required by OpenAI's specific models.
So it just discards any unnecessary functions that consume excess power.
Exactly. When you strip away the unused architecture, the power consumption drops dramatically. When you apply that efficiency across millions of users and billions of daily queries, the cost savings are massive.
This totally explains why big tech companies are willing to spend so much capital on hardware design. Building custom silicon is a direct path to better profit margins on the software tools we use every day. They are spending billions of dollars on hardware upfront, hiring companies like Broadcom so that the software side of the business operates at a fraction of the cost over the next decade.
That is exactly right. So moving from the winners, we really have to look at the other side of the trade.
The losers.
Right. If massive tech companies are spending their budgets on custom-designed chips for specific workloads, that capital is naturally moving away from companies that sell off-the-shelf, general-purpose hardware. This brings us to the potential losers, specifically concerning concentration risk in the graphics processing unit market.
We definitely have to talk about the absolute giant in this space. NVIDIA, ticker NVDA, is the primary company in this category.
Yeah, and to be clear, NVIDIA is not broken by any means. They have an incredibly strong business with record-breaking revenues.
Right, they are doing fine.
But this news creates a question for investors regarding future demand. If major artificial intelligence laboratories build their own inference chips, a portion of future demand will move away from external graphics processing units.
Which impacts NVIDIA directly.
Yes, and advanced micro devices, ticker AMD, also faces pressure here. AMD is actively trying to win more market share in artificial intelligence accelerators. But if customers opt for custom chips over merchant accelerators, the opportunity for AMD shrinks.
Just to clarify the terminology for you guys listening, when you say merchant accelerator, you mean a chip that is built to be sold to anyone.
Right.
A standardized product on a shelf, as opposed to a custom-built solution like Jalapeno.
Correct. NVIDIA and AMD build merchant accelerators. They design an architecture that works very well for a wide variety of customers, package it, and sell it on the open market.
But hold on, I want to play devil's advocate for a moment regarding NVIDIA. Everyone talks about NVIDIA's software moat.
Right, CUDA.
Yeah, they have this proprietary software platform called CUDA that developers use to communicate with the chips. Developers have spent years learning it. Can OpenAI really just walk away from NVIDIA and use a custom chip without breaking their entire software ecosystem?
That is a very critical point.
Hmm.
NVIDIA's software mode is exceptionally strong in the training phase.
Okay.
When you are training a new artificial intelligence model from scratch, you absolutely rely on that established software ecosystem. But inference, the phase where the model just answers questions, is different.
How so?
Well, OpenAI controls the software layer of their own models. Because they dictate exactly how their models operate, they have the capability to write specific code that communicates directly with a custom chip like Jalapeno.
So they just bypass the need for a general-purpose software ecosystem.
Exactly. That makes NVIDIA much more vulnerable in the inference market than in the training market.
That makes total sense. So the reliance on standard hardware drops once the model is already trained and ready for the public. That leads right into the general-purpose challengers.
Right, Intel and Qualcomm.
Yeah, we are looking at Intel, ticker INTC, and Qualcomm, ticker QCOM. Intel is attempting to rebuild its data center and its foundry business, and Qualcomm is trying to expand from smartphones into artificial intelligence, personal computers, and data centers.
Right.
But why can't Intel and Qualcomm just sell directly to these AI labs? Like, why can't they just pivot their massive operations, walk into OpenAI's headquarters, and say, hey, we will build exactly what you need?
The challenge lies in the fundamental business models of general-purpose chip makers.
Okay.
OpenAI's move to create Jalapeno shows that customers with massive budgets want hardware built for very specific workloads. General-purpose chips, like the central processing units Intel is famous for, are designed to be highly versatile.
They can do a lot of things.
Right. They can run a web server, manage a complex database, run a desktop operating system, and process AI tasks. But that versatility requires extra transistors, complex instruction sets, and way higher power consumption.
Let me make sure I'm visualizing this correctly. Are we basically talking about a Swiss Army knife versus a scalpel?
That is a great analogy.
Like a general-purpose chip is a Swiss Army knife. It has a screwdriver, a corkscrew, a tiny pair of scissors. It can do a bit of everything, but it is heavy and bulky. Jalapeno is just a scalpel. It does one exact thing flawlessly and efficiently.
That is a perfect way to look at it. OpenAI does not need a Swiss Army knife. They need highly optimized inference for their specific neural networks. Creating a custom chip strips away the corkscrew and the scissors.
So for Intel and Qualcomm, pivoting their massive design operations to compete on single-purpose custom silicon against dedicated design partners like Broadcom is a much tougher path.
Oh, absolutely. It sounds like trying to steer a massive cargo ship to chase down a speedboat.
Wow, yeah. Intel has spent decades building the best cargo ships in the world, optimizing for versatility and general computing. Asking them to suddenly build a specialized racing boat to compete with Broadcom is an incredibly difficult operational pivot.
Exactly. The engineering cultures and the economic models of those companies are built around selling millions of identical, versatile chips to thousands of different customers. Transitioning to a model where they build one highly specialized chip for one specific customer requires a completely different approach to research, development, and margin expectations.
Beyond the companies designing the chips, we also have to look at the hardware companies responsible for assembling the physical servers.
The metal boxes that actually hold these processors.
Right. They are facing new challenges as artificial intelligence labs take more control over the overall system architecture.
Yeah, the final group we need to evaluate includes the hardware assemblers. So that is Dell Technologies, ticker DILL, Hewlett-Packard Enterprise, ticker HPE, and Supermicrocomputer, ticker SMCI.
Okay.
Overall, artificial intelligence server demands may still grow, but investors might become far more selective.
Why is that?
Because AI labs and hyperscalers are controlling more of the chip design and the overall system architecture, these hardware companies could lose their pricing power.
So are these hardware companies basically at risk of becoming assembly line workers rather than the architects of the data center?
Pretty much, yeah.
Because in the past, a company might rely heavily on server manufacturers to design the optimal system, figure out the cooling, and arrange the memory. Now, OpenAI and Broadcom are dictating the exact specifications from the ground up.
Exactly. The hardware assemblers are just following a blueprint handed to them.
So the key question for the market is whether these assemblers can capture strong margins, or if they will simply be forced to compete strictly on price to assemble systems around chips designed by someone else.
That margin squeeze is a critical factor for investors to monitor closely. When the end customer dictates the motherboard layout, the exact cooling requirements, and the specific networking interfaces based on their own custom chip, the server assembler provides way less unique value.
Their role becomes highly commoditized.
Right. If Dell, Hewlett-Packard Enterprise, and Supermicro are all just building the exact same box based on OpenAI's blueprint, the only way they can compete for the contract is by lowering their assembly price.
Which eats directly into their profit margins. They go from being strategic technology partners to just being the lowest bidder on a manufacturing contract. That is a completely different business reality for them.
It really is. So as artificial intelligence moves from the resource-heavy training phase to everyday, widespread inference, how will the balance of power continue to evolve between those who design the custom chips and those who physically assemble the systems? That is a dynamic that will determine the next generation of hardware winners and losers.
This is not financial advice or buy or sell recommendations. This is purely the opinion of the author.